Hi everyone, welcome back to Everything Mathematics. Today we are going to derive the double angle identities for sine and tangent. Let's take a look. Before we do that, we are going to assume some prior knowledge. We will assume that we are pretty familiar with two identities. The identity for the sine of a plus b and tangent of a plus b. You may remember that we derived some of these identities in previous videos. I'm going to link all those videos in the description below. So again, the identity for the sine of a plus b and the identity for the tangent of a plus b. We're going to keep that in mind as we move forward. Now we're going to go ahead and see exactly how to derive the double angle identity for sine. Why do we call it double? We call it double because if you notice right here, we are doubling angle A. We're multiplying A by 2. That's why the identity takes on the name double angle identity. So what is that equal to? So what I am going to do in order to begin the derivation of the identity is to re-express 2A as a sum of angle A. 2A will become A plus A. Let me write that down. So we're going to have sine of 2A equals to the sine of A plus A. That's what I mean by a sum right here, A plus A. And now by having the sine of a sum of two angles, A plus A, I can use the identity for the sine of the sum of two angles. So the identity goes like this: sine of A times the cosine of A plus sine A times cosine of A, if you notice. And now notice how these two terms are identical. So because they are identical, I can simplify. In other words, this is like having x plus x. We're adding two identical terms. And whenever we add two identical terms, we get 2x. So here x is like this entire expression, sine A, cosine A. And notice how here it repeats again. So then this is going to become 2 sine A times cosine A. And here is the double angle identity for sine. Pretty straightforward. It was an easy derivation. So the sine of 2A is always equal to 2 times sine of A times cosine of A. In a similar way, we're going to go ahead and now tackle the derivation for the tangent of 2A. So the double angle identity for tangent. So we're going to start by re-expressing 2A as a sum. We know that we can do that by writing it as tangent of A plus A. Again, here is the sum of angles. And now we're going to use the sum of angle identities involving tangent to be able to move forward. So the tangent of a sum is equal to the tangent of A plus tangent of A again. All this divided by 1 minus tangent of A times tangent of A. And I want you to notice right here, look at this expression. This is like having x times x, which is equal to x squared. And here in the numerator, again, we have something like x plus x, which is equal to 2x. So then that's how I'm going to move forward with simplification. I'm going to have 2 tangent A in the numerator, and in the denominator, we're going to have 1 minus tangent squared A. And this becomes the double angle identity for tangent. I hope that you found this lesson helpful. Now the goal, I am sure, will be to use these identities to solve a wide range of problems. But you know that using the identities is important, but equally as important is to know how they come about, to see how exactly they are derived, why are they there. And I'm hoping that you get to appreciate that now. Until next time, bye everybody.